Hello, Math Study students, and welcome to your online lesson. Today we'll be using the cosine rule to find sides and angles of non-right triangles. Previously, we've used our trig ratios of sine, cosine, and tangent to find missing sides and angles of right triangles, but now we'll be able to find the sides and angles of any triangle, including those that are not right triangles. We will know we're successful when we can efficiently find missing sides and angles of non-right triangles. So since we're using the cosine rule, we need to know what that is. Now, once in a while, you hear this referred to as the law of cosine as well. So it's the exact same thing. And what we have is in any triangle ABC, a squared is equal to b squared plus c squared minus 2bc cosine a. So it's kind of a mouthful, but there should be some things that look familiar. Number one, if I start over here on the left, I've got a squared plus b squared, a squared equals b squared plus c squared. And that right there should remind us very much of the Pythagorean theorem. Now, it's not quite in the right order. Usually c is by itself, but all of these letters are essentially interchangeable. So that's pretty familiar there. Now, if you look what's left over, we've got a b and a c. And you'll notice that both b and c were already on the same side of this equation. The b was right here, and the c was right here. And so both of those appeared, and they're just appearing one more time. And then finally, we have the cosine of big A. Well, big A we know is an angle, much like we see here on our triangle. And it is opposite of this A over here. In our last video, we referred to something known as an included angle. An included angle. And an included angle is the angle that is formed by two sides, or any two sides that create an angle, that is their included angle. Well, in this formula, over on the right side, again, we have the b and the c. It appears twice. B is squared, and then later on, it's getting multiplied by the c and the cosine. And c is squared, and then again, later on, multiplied by that, -2, the b and the cosine. Well, if I circle b and c and ask you what is their included angle, it is a. And so over here, again, on the right side of this equation, I have the b, I have the c, the b and the c appear again, and cosine of a. So they're like a club. They're included. They all stick together. And a, which is opposite, little a that is, which is opposite of big A, he's all by himself. And I've underlined it in green over here. So a is by itself, and in the equation, a is by itself. So another way to say this formula is we're adding up two sides that include an angle, and then subtracting 2 times those two sides times the cosine of their included angle. Or not, they just all group together, all these people here, the two sides and the angle that they form. So enough talk. Let's actually try this formula out here and see what happens. So our first example, find correct two decimal places the length of BC. So BC is this side over here, and I'm going to refer to it as little a because it's across from or opposite of big A. Well, the first thing I want to do in any one of these things is write down my formula. And so my formula, at least the way it was written on that last slide, is a squared is equal to b squared plus c squared minus 2. And then whatever letters I just wrote down, which were the b and the c, getting multiplied together, once again, it is the cosine rule. So we have cosine, and then the angle, and that would be angle A. Now, on this example, I've got the letters all exactly where they would need to be in the formula. So A is what we're trying to find, so I'm going to leave that as a squared in my formula. B, we know, would be across from angle B, so that would be like this 13 here. So I'm going to have 13 squared plus C, which is across from big C, which would be like this 11 here. So I'll have 11 squared minus 2 times that same stuff, times the 13 and the 11 times cosine of angle A. Well, angle A is labeled nicely here, but as we said on the last slide, the important thing is it's the angle that's included with the two sides that we mentioned. Well, which two sides do we mention? 13 and 11 got used twice here. Well, the 13 is here, the 11 is here. What is the angle that those two sides form? And that is angle A, which has a measure of 42. So cosine of 42. Just like before in our trig ratios, you can only take the cosine, sine, or tangent of an angle. So cosine of 42. Well, we can get this done in 2 steps. This looks like a lot, but in our calculator, we can just literally type 13 squared plus 11 squared minus 2 times 13 times 11 times cosine of 42. And when I hit enter on my calculator for that, I end up with approximately 77.460579991, on and on and on. And now I'm almost done with this problem already. The only thing is I don't have a alone. I have a squared. So just like when we did the Pythagorean theorem, if we get our variable alone but it still is a square, we need to square root. So I'm going to square root both sides. And ideally I can just keep it on my calculator, press second the square key, which gives up the square root, and press second negative sign, which will bring my answer up, and I will get the square root of 77.46, on and on and on, which approximately becomes 8.80. Our units was centimeters, and that is our value of A. Now, could we have done this in 1 step? Yes. If we go back all the way to our very second line here, when I'm plugging all this into the calculator, if I want to get just A without having to do the extra square root, I can square root right from the beginning. And that's just going to make 1 extra set of parentheses that goes around everything else. So you just need to remember, when the calculator does a square root, it automatically opens a parenthesis, and then you just want to close it there at the end so that we end up square rooting all those, and you can go directly to your answer. So the hardest thing here is just the setup. And the best way to practice a hard setup is to try doing it again. So for our next example, we do not have any letters here telling us what is A or B or anything like that. And the honest answer is it doesn't matter. What we're going to focus on is the groupings of our triangle. Well, let's start by writing our formula again. We have A squared equals B squared plus C squared minus 2 times BC, which are the 2 letters that are on the right side of the equation, times the cosine, because it is the cosine rule, of angle A, which is the opposite of the side that was all by itself on the left side of the equation, or the angle that is included by the 2 letters B and C on the right side. Now let's start filling things in. Well, the thing that we want to find is x. And you'll notice we have 2 sides already, 14 and 21, and we also have the value of their included angle, 47. So these guys are that family. They're the ones that are going to stick together on the right side of the equation. X is the one that's all alone. No angles nearby that we're using anyway. And so x is the loner, so x is going to be like our a squared. It's the thing that's all alone here. Then we have our B, and it doesn't really matter whether we use 14 or 21, but the B and C are going to be the 2 sides that include our angle, or the 2 sides that form this angle of 47 that we have here. So I'm going to take my 21 and my 14. I'm going to go in that order. 21 squared plus 14 squared minus 2 times those same values, 21 and 14, times the cosine of the angle that is in between those, or included by those 2 sides, 14 and 21, which is the value of 47. Sorry for my bad penmanship there. So now we're just going to punch all this into the calculator again. Let me see if I can clean up that. So cosine of 47. There it is, better. All right, so we punch all this into the calculator, and we end up with x squared is equal to 235.98, on and on and on. Am I done with this problem? I'm so close, but I still have x being squared. So I need to square root the x to get rid of the squared symbol, and I do the same to the other side in algebra. So our final answer is going to be x is equal to approximately 15.4 centimeters. Now, we didn't do this on the last one, but it's always great to sort of check, is this reasonable? Now, I don't know if this picture is exactly to scale, but if I had to guess, I would say the 21 on the picture looks like the longest side. 14 definitely looks like the shortest side. And the value that we came up with is somewhere in between those values, 15.4. So it certainly seems reasonable, again, not knowing exactly the scale of our picture. All right, we're going to do one last example. You'll notice in both of these first two examples, we found missing sides. Now let's try finding a missing angle. All right, so for our last example, no triangle is drawn, but it says in triangle ABC, if AB is 7 centimeters, BC is 8 centimeters, and CA is 5 centimeters, find the measure of angle BCA. So there's really no way to do this without drawing a picture first, or at least to do it effectively. I'm not sure if this will totally be to scale, but I'm just going to label this as A, B, and C, mostly just for reference. And then it says AB is 7 centimeters, and we've got BC is 8 centimeters. CA is 5 centimeters, and we are trying to find the measure of angle BCA. So BCA would have C as the vertex. BCA. So C is what we're actually looking for, this angle right here. And I'm just going to use the capital C as my variable. So I'm going to start filling out what I know, starting with the formula that I have here. Now, I'm going to put little a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of their included angle, which is A. Now, as I start filling these in, there isn't a missing side. So figuring out what little a is a lot harder. And if we actually look at the opposite of this capital A that we have here, that would be little a is 8. However, in my formula, we need to remember that everything on the right side are two sides and the included angle. And the two sides that I have that have an included angle, or an angle at least that I'm looking for, since I'm looking for angle C, or BCA, the two sides that include it are the 8 and the 5. So that means that 8 and 5 have to be my B and C. So 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of the angle I'm looking for. And even though my formula says I'm looking for angle A, I know in reality I'm looking for the included angle C. So then the question is, what goes over here where we had our A squared? And our A squared is the one that is opposite or across from that included angle that we had. Well, since our angle that we're looking for is C, the side that is across from or opposite of C is 7. So our little a is going to be 7 squared. So that's our setup here. Once again, remind yourselves that the 8 and the 5 include the angle C that we are looking for. So that's the important part with the setup, and arguably the most confusing thing that we have going on here. Now, I wish this was as easy as our last two examples, but we're going to have to do some algebra here. So I'm going to treat this basically as 3 groups because we have 3 terms. Or I can combine this at least into 3 terms. I'm going to group these two guys together. So I'm going to have 8 squared, which is 64, plus 5 squared, which is 25. And I end up with 89 for that one. And then I'll do all of this right here. And so I've got the 2 and the 5 and the 8, which is going to become 80. But there's a minus sign in front of it, so it's minus 80 cosine C, a variable there. And then finally, all that equals 49. Now, I'm trying to get my variable alone, but there's 2 terms on the right side of the equation. There's the 80 cosine C, which I cannot combine with the 89. Let me say that again. I cannot combine it with the 89 because the 89 is just a whole number, whereas the negative 80 cosine C has this variable trapped in it. So I'm going to get rid of this 89 from both sides. These will cancel out, and then I end up with negative 40 on the left side of my equation. Now, negative 40, what's left on the right side? Negative 80. Do not lose that negative sign. And then we still have 2 steps left. The first step is, let's get rid of this negative 80. So I have negative 80 that was multiplying the cosine of C. When I divide it, these cancel out, and negative 40 divided by negative 80 becomes 1/2, or 0.5. I'm going to bring my work up top here, and so I end up with 1/2, or 0.5, equal to cosine of C. Well, I'm trying to get C all alone, so there's 1 step left. I need to do inverse cosine right here. So inverse cosine of this will cancel out those cosines, but whatever I do to one side, I have to do to the other. And we end up with a really nice value here of angle C being 60 degrees. So a lot of work going on here. Again, the thing to keep in mind is that we grouped our initial setup based on the two sides that we knew and their included angle that we were looking for. A lot of algebra, focus on keeping your negatives, not combining unlike terms, and then in the end, it ends up becoming a very simple sort of trig problem like we did with right triangles. All right, more practice next class. Till next time.